Okay, so we're going to talk about some properties that belong to solutions. So, one thing that I want you to remember is that when we talk about solutions, we're going to be really referring to how the boiling point and freezing point are going to change, how they're going to elevate the boiling point or drop the freezing point. And so when we start talking about the elevation or depression, we are going to be looking at how if we add something to a solvent, how we'll raise the boiling point. Just as if you are cooking noodles, you add a little salt to water and it raises the boiling point so your noodles cook faster. In the same way, if I add a little salt to water and I try to freeze it, it lowers, so it actually freezes below zero. And you can do that by adding like rock salt to ice when you're making, and then you can make ice cream. So that's one of those ways. So that's what we're going to be working on, is these properties. Note I have two tables that I attached, and so you are going to need to access those two tables. They're table 15.4 and 15.5. So please access those two tables as we go through this so that you understand where I'm getting my K at, or constant for elevation of boiling and constant for depression of freezing. So those constants are coming from there. Okay, so now let's start with the math. So when we start looking at this, we got to see what they're asking for. So what are the freezing points and boiling points if we have a molality of 0.25 solution of a non-violent, non-electrolyte solution? Just for FYI, this is going to be water for us. If you look at the chart, it's the only one that does it. It's not flammable. It doesn't have any other properties. So the only one that we have available to us is water. And honestly, water is going to be your non-violent, non-electrolyte stuff, is going to be all dissolved in water because water is nonpolar in the universal solvent. So let's start with our start by finding our elevated boiling point constant. So let's start with our delta T. B is equal to KB plus or times M. So right now we don't know what our delta TB is. That's what we're solving for. We have our molality, which is 6.25 molar. We can look on our chart, again, that table that I gave you, to find that the boiling point elevated constant, or KB, for water is 0.512 degrees Celsius times molality. So we multiply those together and we get our elevated temp to be 0.32 degrees Celsius. Again, these cancel out. However, that is not our answer yet, because we know we need to find the boiling point, and so that's what we have to look for. So on that chart, you're also going to see what the boiling point of water is. And water's boiling point is 100 degrees Celsius. I said we're elevating this. Well, we are. We added something to water, so now it's going to boil above. So because of that, we're going to add 32 degrees Celsius. And then the boiling point of water becomes 132 degrees Celsius. We are not going to follow the 3 significant digits rule on this, just because we have to see what that elevated point is. Okay, so now that we found that, we're going to do the freezing point. So again, we are going to find our freezing point depression. So how far does it drop below freezing? So we still use Kf times M. We still know what our molality is. That is not changing. But when we look at our table, we do have a different Kf than KB. So the depression constant is different than the elevated constant. So make sure that we are looking at that table to find that constant. And again, that is in an attached document. 86 degrees Celsius times M. And so then our delta F, that is going to be equal to 1.16 degrees Celsius. Again, these cancel out. Again, we said that we have now the constant for the depression point, and since we are depressing it, we are dropping the temperature. We have to look. Oh, I apologize. I wrote an E there. I need an F. We need to find the freezing point. So we're going to add something to it so it's going to drop below freezing. So we start with the freezing point of water, which is 0 degrees Celsius, and we subtract our 1.16 degrees because we're depressing it, which means we're going down further, which means we have a negative 1.16 degrees Celsius for our depression point. So these two are our answers for our freezing point and our boiling point. So when we add that to a solution, that's where it drops to. Oops, spelling error. This should be sucrose. That should be a C in there. Okay, so it says again, what is the boiling point and freezing point? It gives us the molality of the solution, and it gives us two things. It gives us sucrose in ethanol. All right, so that's really important to know. So this is our solute. This is our solvent. We only care about our solvent. We are not going to look for our solute. We are just going to see how our solvent is changing because it's still what we have is the liquid. The liquid will obtain those properties. Once you dissolve, your properties kind of change, your physical properties change. So that's why we're looking at that. So we're going to, again, start with what we know. So we are going to have our delta be our point, boiling point elevated. And so we are looking for our Kb times m. We know our m right here. It's 0.4 molality for that solution. We look at our chart. When we look at our chart, you're going to see your K of F, or your constant for your elevation constant, is going to be 1.22 degrees Celsius times molality. These will cancel out. So then your delta TB becomes 0.488 degrees Celsius. Again, that is not our final boiling point. So we have to find our boiling point. We actually look at the actual boiling point of our solvent, which would be ethanol, and the boiling point of that is 78.5 degrees Celsius. We're going to add that because we're elevating it to 4.88 degrees Celsius. And in this case, you get 78.98 degrees Celsius, or 79 degrees Celsius would be the answer for the boiling point of this. So now let's look at the freezing point. Again, we're looking at a depression, so our K of F is going to be different because we are not boiling something, we are freezing. Our molality stays the same. And if we look at our chart, we're going to see our K of F now becomes 1.99 degrees Celsius divided by molality. These cancel out. Your delta F is equal to 0.796. But we have not found our freezing point because we are looking for that deposition. So we look at the freezing point of our solvent, which would be ethanol, which is negative 114.1. We subtract the deposition that we just found, and we should get a number of negative 114.896 degrees Celsius. And so, again, if we rounded this to three significant digits, 115 is a much different when we talk about 2/10. So we kind of want to leave those out a little bit further, which is totally fine. We'll probably do more like 5 significant digits for this. This problem's a little bit different. It says, hey, lab techs determine the boiling point elevation to be 1.12 degrees Celsius. What is the molality of this solution? So we got non-violent, non-electrolyte. Do you remember what I told you that's always going to be? You bet. That solvent is water. So because we're looking for this, we need to look at our chart and find our K sub B of water, which when we look at that chart, we get 0.512 degrees Celsius times molality. And so that would be our K sub B. So then we just have to put it into the equation because we are still going to use the same equation here. So then we just put 1.12 degrees Celsius is equal to 0.512 degrees Celsius divided by molality times M. M, or your molality, is going to be equal to 2.19. So that's not so bad. That's a lot easier. We could also, if they gave us the freezing, we would do the exact same thing, just our K of F would be different than our K of B. We could do the exact same thing for that. All right, so a student, this could be you, dissolves 0.5 molars of a non-violent non-electrolyte solution in 1 kilogram of benzene. Notice this is dissolving, so benzene, this is your solvent. That's your solvent right there. What is the boiling point elevation of the resulting solution? So for this one, it's not asking for the boiling point, so we can simply use our delta TB is equal to KB times molality. We don't need to go any further than this equation because it's not asking for the boiling point. It's asking us to actually solve for that elevated boiling point. How far is it going to elevate? And so we're just looking for that. However, we don't have molality in here. Well, molality is equal to moles divided by kilograms, right? Well, they gave us 0.5 moles divided by 1 kilogram. And so then we know that we have a molality of, 0.5 M. And so that becomes our molality for this solution. And so when we're looking at our delta TB, we actually do know our K sub B because we can look. We have benzene as our solvent. So we know that benzene's KB is 2.53 degrees Celsius times molality. And then our molality we just said was 0.5. And so our delta TB for this equation is going to be 1.25, or if you do 1.27 degrees Celsius. Both are correct answers. And so this is the more accurate number, just to let you know. So that is how we find those properties. And we're really looking for, if we add something to a solvent, how it's going to elevate its temperature or depress its temperature, lower its temperature for freezing and boiling point.